Hello, everyone, and welcome to our weekly cyber threat intelligence briefing. Today is July 10th, which is also National Pina Colada Day. And we'll be covering most of the recent cutting-edge trends that our threat intelligence team is witnessing in the trenches. My name is Keith Wojcicki, Global Head of Threat Intelligence, and this week we are joined by Senior Vice President George Glass, Vice President Dave Truman, Vice President Mikesh Nagar, Senior Associate Ryan Hicks, all from the Cyber Threat Intelligence team. We'll be covering the following trends that our team is concentrating on this week. It's back again, open redirect phishing, PLUGX malware, and BLACKCAT using Malvertising. And Dave is going to finalize it up with some Ghostscript vulnerability. So with that, I'm going to turn over to George. George?
Thank you, Keith. Yeah, so we've been tracking the use of open redirect in phishing emails for a while now, but since May, we've seen a pretty significant increase in the amount of just sheer volume that we're seeing. Other campaigns that we saw throughout May used open redirect vulnerabilities, and we're using that to hijack the reputation of domains. So you may remember we covered a campaign that used the political commentator Bill O'Reilly's domain for this very attack, and we've started seeing this again in the last 2 weeks or so. The differences this time is, although they're still using the original domain for good reputation, there are a number of other redirects following the initial one. So on some of the samples that we've analyzed, there's up to 5 redirects before landing on the final phishing page. Interestingly, the actor in the middle phish kits are enabling attackers to capture the two-factor authentication token. And in the campaigns that we saw and analyzed, some of them could enable a threat actor to automate a login to a cloud or Office 365 session and capture the session tokens that are provided to the actor there as well. A particular campaign that commenced on July 3rd. So, again, as we saw in May, tends to be happening around public holidays, used a DocuSign law, as you can see on the right-hand side there, very convincing looking. And this particular campaign seemed to not really be restricted by a particular industry sector or geography, but most of the phishing emails appear to be in the English language. So what we are doing here is recommending that customers and clients continue to educate their users on some of these phishing techniques, and for administrators to be very sensitive to the fact that these campaigns are coming from multiple sending domains, which often carry the same phishing lure, in this case DocuSign. So we expect that to probably continue over the next months. The actors behind this are clearly very capable of performing these large spam campaigns. So just want to bear in mind there. And that's it for me. I will hand back to you, Keith. Thank you very much.
Thanks, George. Appreciate it. Now we're going to turn it over to Ryan to talk about PLUGX malware.
Thanks, Keith. Hi, everyone. There have been reports last week in open source that a nation-state actor used HTML smuggling to deploy PLUGX malware to victims predominantly in Europe. For this week, we're really kind of focusing mainly on that kind of initial access, focusing on the HTML smuggling aspect. And now HTML smuggling is a technique, not a particularly new technique, we've observed before, where actors embed malicious content inside seemingly benign HTML files, which could potentially evade network-based detections that could otherwise detect the malicious payload itself. When a victim opens the HTML file, the embedded payload is decoded, saved as a blob of data, and a URL object is created using JavaScript functions within the HTML file. The code within the file invokes a simulated user click, and then that initiates effectively kind of a download of the payload to disk with the desired sort of file name that the actor chooses. In this campaign, two sort of chains of HTML smuggling were observed, and both of which are represented on the image on the right. Those kind of two above and below kind of chains leading to PLUGX. The first of which was at the top, which is through compressed files, which is similar to what we've seen before. The HTML file it contains a zip archive, which in turn contains an LNK file, and that executes runs PowerShell commands to extract another archive containing legitimate RoboForm password manager, as well as the PLUGX DLL itself. And the second method, which is the one below, which is with JavaScript, so HTML containing JavaScript file, and when that is executed, it downloads, contacts command and control, downloads and runs a Windows installer file. And similar to before, this then drops and executes the legitimate password manager and the PLUGX DLL. The purpose of the kind of mentioned the legitimate password manager software, and that's utilized in each chain. It appears to be a way to load the PLUGX DLL through a side-loaded DLL loader. And PLUGX itself is a remote access Trojan, and that provides threat actors with a foothold in the victim's environment to deploy further tooling. In this case, there were no kind of new observations of PLUGX as kind of the standard PLUGX that we know. So again, kind of focusing really on that, how PLUGX is actually delivered. And looking back at HTML smuggling, in December last year, we observed this similar technique, and that was in the form of HTML embedded zip file used to deploy Quackbot, very similar to the chain at the top there, except it was zip that contained an image file that then contained an LNK. So very similar chains, but again, variations in this new campaign. Because of these sort of changes, we're working to find opportunities to detect these new variations alongside our existing HTML smuggling detections. And of course, any new detections will be pushed to customers. And IOCs for this reported campaign are now in the Kroll indicator of compromise feed. Back to you, Keith.
Thanks, Ryan. Appreciate that. And now we're going to turn over to Mukesh to say how BLACKCAT is using Malvertising.
Thank you, Keith. So in recent observations by Trend Micro, they've detected a concerning development involving actors associated with BLACKCAT ransomware. These actors have started to employ a malvertising technique to distribute rogue installers of a very popular file transfer application called WinSCP. According to the researchers, the actors have adopted malvertising as a means to distribute their malware by creating a cloned web page that mimics legitimate organizations. In the case they observed, this was WinSCP. Our CTI team previously reported on a similar tactic where a threat actor used GIMP, which is an open source image manipulation tool application, as a vehicle to distribute the VIDAR stealer. Once the user downloaded and executed what is supposedly the WinSCP application, Cobalt Strike was installed on the host. This allowed a backdoor access for the threat actor, allowing them to proceed to download other various programs to execute different malicious activities. These activities included reconnaissance using legitimate tools such as AD-Find, as well as enumerations using PowerView, lateral movement through PSExec, as well as employing antivirus invasions such as KillAV-BAT. As depicted in the figure on the right of the screen, the attack chain also involves stealing top-level administrator privileges for post-exploitation activities. The actors also attempted to access backup servers and establish persistence by leveraging remote monitoring and management tools such as AnyDesk. We recommend administrators conduct regular security awareness training sessions to educate their employees about the risk of malvertising, phishing, and downloading softwares from unauthorized sources. We also recommend them to recognize and identify suspicious adverts, URLs, as well as email attachments and emphasize the importance of reporting any suspicious activities. We also further recommend administrators and organizations to deploy and maintain an up-to-date endpoint protection solutions such as EDRs and NGAVs, and ensure that all endpoints are regularly patched and updated to defend against known vulnerabilities that threat actors may exploit. Thank you. Back to you, Keith.
Thanks, Mukesh. Appreciate that. We're going to wrap it up with Dave. He's going to talk about the Ghostscript vulnerability. Dave, over to you.
On 26th of June 2023, a vulnerability was disclosed in Ghostscript with a CVSS score of 9.8. CVE 2023-3664 described as a flaw that occurs due to mishandled permissions validations for pipe devices. Ghostscript is an open source interpreter for the PostScript language and PDFs. Users will not commonly interact with Ghostscript themselves, but more likely it'll be used on their behalf by desktop applications. On Linux, it is often installed by default, being a required dependency for many other packages such as common Unix printing system or image managing. However, Ghostscript does not exist only on Linux. Whilst it is not part of the default Windows install, it is often used by applications that might get installed on Windows, particularly open source applications for publishing and printing, or proprietary tools that use open source components for these same purposes. LibreOffice, the popular free open source alternative to Microsoft Office, uses Ghostscript. So does Inkspace, a desktop publishing app. In some cases, Ghostscript might need to be installed separately, but it can also be bundled in the install of other applications. This means that Ghostscript might be present on Windows systems without users being aware of it. There was no indication of whether or not this vulnerability was exploitable, and we found no one having claimed to have written a proof of concept for it. So in order to work out if this vulnerability was exploitable and how this might take place, we analyzed Ghostscript and developed a working proof of concept that would trigger code execution from opening a vector file in the embedded PostScript format. In this video, we see two tests. One, we are opening a malicious file with Ghostscript itself via the command line. And two, we change the code that gets executed from a simple executable to running a Visual Basic script that is then executed when the file is imported into Inkscape. In the next slide, we have a video which shows the exploitation and code execution simply from opening the malicious file from the desktop. In this case, the exploited application is LibreDraw, a component of LibreOffice. We recommend for installs of Ghostscript or known installs of Ghostscript updating to the latest version. Updating your Linux distributions to a version that has been security patched. And in order to find any unknown installs, look for in your process logs for your Windows environment for instances of gswin32.exe, gswin32c.exe, gswin64exe, or gswin64c.exe. Thank you. Heath?
Thank you, Dave. Yeah, this is fantastic work by the team here. Again, this is something that only Kroll has right now. So really good work, Dave. Appreciate it. And that'll be all for the webinar this morning. I'm sorry, the briefing this morning. A big thank you to everybody that's taken the time to tune in to the weekly threat intelligence briefing. We do hope you found this session informative. Please enjoy the rest of your day and make sure to tune into next week. Thanks again.